Hello everyone, my name is Shambhavi. Hope you all are doing well. So till now we had studied several topics under the confidence interval topic, right? We had seen about what is confidence interval, we had seen confidence, many things we had seen. We had seen student seed distribution, we had seen n number of things in this topic, right? So there were a lot of formulas which we need to remember, and right now I just can understand it can be a little bit of messed up and all those things. So basically now today what we'll be doing is that we'll be doing a quick revision of all the important formulas that we had seen in this under the confidence interval topic. Right, so there was very many formulas, so I just will take a one short video. In that basically we'll be discussing about all the formulas which we have in this confidence interval topic. Right, so let's begin up with the things for here, and I will just take one color and let's start it. So right, so I'll be writing here, let's say the topic that I would be taking here is, let's say, okay, just one second. The topic that I would be taking here is, let's say, the summary of formulas. Okay, so today we are just going to take one revision of all the formulas which we had discussed till now in this confidence interval topic. Right, so let's begin now with the very first thing, and just let me quickly change out the color so that, right here. Right, so first formula is basically the general form of my confidence interval. That what was the general form? I would just write this thing here, general form of, and I will simply write here CI for the confidence interval. Okay, I'm just not going to write whole of the things here. So general form of CI, that is my confidence interval. So the general form for CI is basically, firstly what we write. Firstly we write the lower value in the very starting, right? We write the lower value, and after that what we just write, we write the upper value. So lower value comma upper value, it is the form, and it is basically equal to, now what is this actually equal to? It is basically equal to point estimate. Okay, I would just add on this point estimate minus error bound. Okay, minus error bound, and second form, okay, just one second, BOUNT, and after that basically we even had that point estimate plus error bound, right? So that was point, I would just add on here estimate, okay, point estimate plus error bound. Right, so this was the general form of the confidence interval which we had seen till now, and even we had just done several questions onto this form, that to find out this form we need to find this and then this and all those things we had done, right? So this is the general form for finding out the confidence interval. Fine, moving towards the second. I would just take different colors for each and everything so that it does not actually get messed up with each other. Fine. So number two, basically now we have basically how to find out the error mean when we have the confidence interval. When you just know the confidence interval, how to find the error bound. Okay, so I would just write here to find the error bound when when you know the confidence interval, right? This is one condition which can come, that how to find out the error bound when you know the confidence interval. So for that basically we have one formula, and that formula is actually error bound. So that is error bound is equal to upper value. Error bound is equal to upper value minus point estimate. So error bound is equal to upper value minus point. I would just write it as here estimate. Right, this is the first thing that comes. After this basically we have even one more thing which we have even discussed also in our video. So let me just tell you that thing as well here. So second one is basically, so I would just write here as error bound is equal to, and that is actually upper value. So here I have upper value minus lower value, and whole of the things are actually divided by 2. Right, so this is another formula for finding out the error bound. Right, I hope you just got the idea. Now let me just quickly take another different color. Right, this one here, so we just write on there as 3. Fine, now what we have, I have even many more things in this. So we had discussed about the single population, right? We had discussed about the single population. Then we have single population mean, right? Then we had discussed about known standard deviation, right? We had seen about known standard deviation, And then we had even discussed about the normal distribution, right? So we had even discussed about the normal distribution. So after, if I just have all of these things, so basically how can I just find out the value for the EBM? Okay, so for that, basically if I just have all of these values, so finding out the EBM is super easy. I would simply write EBM is equal to, that would be my Z score alpha by 2. Okay, just let me make alpha more clear. That would be like this, alpha by 2, right? And after that, basically I have a multiplication sign, and then I have here, I have sigma upon under root of n, right? So if I have all of these things known, then basically these are the things which I can use here. And basically then the confidence interval format, then the confidence, so here I would be adding the confidence interval, the confidence interval format is, and I would be adding that thing here, that it is x bar minus EBM, okay, comma, and it would be x bar plus EBM. Okay, so it's x bar minus EBM and x bar plus EBM. Even we had just seen this thing many a times, but today we are just gonna do a, like, we are doing a revision, so I'm just revising all of the things. Right here, after that my next color comes this one, and I would be adding the number as 4 here, right? So number 4, in which we had covered about the single population mean. Single pop, I would just simply write the population as pop, okay? So that is single population mean. And then we had seen about the unknown standard deviation, okay? Unknown, I would add here standard, and here we have deviation. So unknown standard deviation. After that, it was students, I would add students T distribution. It was after that students T distribution. Alright. And basically when we have the students T distribution, all of these things, and we have the degrees of freedom. So how we just find out? We just find out DF is equal to n minus 1. Right. And what is the formula for finding out the EBM? So instead of that Z score, we just write here T score, and T, and it is basically alpha by 2, and multiplication which is s upon under root of n, right? This was the formula which was applied when we were having this thing, right? Fine. Now come to the next one. So fourth is actually done here. Now moving towards the number 5th. So let me take some color here. Let's say this one, right? So now discussing about the 5th one. Now till now we had just discussed about the student-C distribution and all those things. Now comes the topic about single population. So I would just add that single population proportion. Okay, just 1 second. Let me write it like it is actually readable to you, right? So it's actually single population. So it's single population proportion, right? We had discussed this topic actually a little bit recently itself, right? Single population proportion, and we had seen the normal distribution. So basically with using of the normal distribution for a single proportion, what formula we had applied? So that was P dash is equal to x upon n, right? X was the number of trials for the success, and n was basically the sample size, right? This was the things that we have applied. And how do we just find the error bound for the population proportion? So EBP was having the formula as z of alpha by 2 multiplied under root of P dash multiplied by Q dash upon n, right? And what was the basically relation between P dash and Q dash? So P dash plus Q dash was equal to 1. This was the relation which we were having between the P dash and the Q dash, right? Now basically what was the confidence interval format that we're having here? So I'll be adding the confidence interval. So the confidence interval format. So that I would be adding confidence interval format, and coming down I would be just writing here as P dash minus EBP. P dash minus EBP, comma P dash plus EBP, right? This was the confidence interval format that we were having for this, right? And after that we had even discussed about the point estimate. So let me just now take one another. Okay, let me do it from this side only. Let me just take one color, and basically now we'll be writing the point estimates, right? So I'll be adding the number 6 here, and that is basically point estimates, right? So I would be just writing that thing here. So it is basically point estimates are actually basically, so x bar is a point estimate, x bar is a point estimate for mu, right? X bar is a point estimate for mu. Let me come down. And yes, now basically p dash. So is a p dash is a point estimate. P dash is a point estimate for rho. Okay, and after that basically s is a point estimate. S is a point estimate for, and that is sigma, right? So these are the point estimates that I have for different things. So these were all of the formulas which we have actually seen in this confidence interval topic. Let me give you a quick revision once again. So the general form for confidence interval was lower value comma upper value, and that is equal to point estimate minus error bound comma point estimate plus error bound, right? After that, if we basically needed to find the error bound when you know the confidence interval, so in that case we were having two formulas. So the first formula was error bound is equal to upper value minus point estimate, and the second formula was error bound is equal to upper value minus lower value divided by 2, right? After then that, if we have known the terms for that was single population mean, known standard deviation, normal distribution. So according to that, if we just wanted to find out the error bound mean, so for that we simply used this formula, which is z alpha by 2. Z is my z square, alpha by 2 is my value which I'll be calculating, and that was multiplied by sigma upon under root of n. Right? So the format for the confidence interval was x bar minus EBM comma x bar plus EBM. Right? After that, if I was having single population mean and then standard deviation and student seed distribution, so in that basically I was having df is equal to n minus 1, as basically my degrees of freedom was n minus 1, and my value for the EBM was t alpha by 2 multiplied by s upon under root of n. After that, I was having single population proportion normal distribution. So my single population proportion value was p dash is equal to x by n, right? And after that, I was having error bound proportion. So that was z alpha by 2 multiplied by p dash into q dash, right? Divided by n. And basically the relationship between p dash and q dash was, so p dash plus q dash is equal to 1. And the format for the confidence interval was p dash minus EBP comma p dash plus EBP, right? This was the format between this basically confidence interval. And after that, basically what I was having, after that I have point estimates, right? So point estimate. So x bar is a point estimate for mu, p dash is a point estimate for rho, and s is a point estimate for sigma. So these were the point estimates that we were having here, right? So basically these were all the formulas, all the things, a quick summary regarding the topic of confidence intervals. Now basically from the next video we'll be starting up with a new topic. So this is all for this video. Till then, thank you and take care.